Yeah, now we have a rational function, and on the numerator, yeah, we have trigonometric function which is sine x, and the denominator we have polynomial, right? So, if you look at the denominator, x is common. Why don't you, yeah, take that out from these two factors? Yeah, so this is your common x of these two terms. I wrote in this way: sine x over x times 1 over remaining term is yeah, x plus 3. Yeah, this one. So limit of two product functions is equal to product of two limits. So limit of this one times the yeah, limit of that. So we know that as x tends to 0, yeah, this term becomes 1. As x tends to 0, this term becomes 3. So that's why you get 1/3. Right, so yeah, so next question, yeah, so function is defined for all real numbers, and when x is not equal to 1, yeah, it is a rational function. When x is equal to 1, which is equal to 4, function value is 4 at 1, right? So why don't you simplify this? You can factor out this numerator. Why don't you simplify? Yeah, when you factor out this numerator, you can yeah, write in this way. So here x is not equal to 1, then you can cross this off, then you left with this term only. So this is a, yeah, is equal to 1 plus x. Alright, so we can see that as x tends to 1, so the function value approaches 2, right? And yep, so limit as, yeah, this is this axis, and this value is equal to 2, because so when you simplify this function, you get 1 plus x. As x approaches 1, 1 plus, yeah, 1 plus x, yeah, convert, yeah, approaches 2. That's why this, yeah, this value. So which is not equal to the functional value? Functional value is 4, therefore f is not continuous at 1. Yeah, this is wrong. Yeah, f of x is because it is defined. F of 1, yeah, f of 1 is equal to 4, it is defined. Yeah, these two are correct statements. Yeah, so that's why I answer 1 and 2 only. Yeah. Now let's look at this yeah, left limit of this so yeah, difference of these two functions. So we know that limit of difference of functions is equal to difference of limits. So therefore limit yeah, so as x tends to 1 from the left hand side of this function, yeah, this one is equal to yeah, so limit of this one minus limit of this, right? So what is the limit of this as x approaches 1 from the left hand side? So let's find that first. This is the, yeah, flow function or integer, yeah, flow function. So that means the greatest integer not greater than x. So this is the, yeah, yeah, this is the greatest integer in this area, right? This is the greatest integer, so in this area. So 0 when x is less than yeah, in between 0 and 1. When x is 1, this flow function takes 1, and for other values, let's say x is greater than 1 and less than 2, then flow function takes yeah, 1, right? So So the limit of this function as x tends to 1 from left hand side is, yep, so you can, so we are interested at this point. So we can see that, yeah, so the function value approaches 0. Yeah, this is the function value. Yeah, so so this bit is, yeah, what is the limit of this function as x approaches 1 from left hand side, yeah, which is 0, right, which is 0. And let's find the limit of this function as x approaches 1 from left hand side. So this is modulus of x, right? So we know that modulus of x is, yeah, so when x is positive, so modulus of x takes itself, and when x is negative, modulus of x is the negative x, yeah, this one. So you know that, so this is a continuous function. So then limit as x approaches 1 from left hand side, and the functional value approaches 1. So this bit is 1, and here you have negative, so negative 1. Yeah, so that's the answer. And the next one, trigonometric function. So limit of this function as x tends to 0. Yeah, you know that sine function is an oscillator function, so it is oscillating between -1 and +1, right? So here, so when as x approaches 0, you know that 1 over x could be positive infinity, negative infinity. So if your x approaches 0 from your left hand side, so then this would be, yeah, negative infinity. If your x approaches 0 from your right hand side, this would be positive infinity. So therefore sine, yeah, so the limit of sine function, yeah, does not exist. That's why the limit is not existent. Now let's take a look at this function here. So this function f, it is defined, this rational function for x is not equal to 0. When it is equal to 0, it takes function value takes k, right? So if f is continuous at 0, what is the value of k? Yeah, very simple. So why don't you simplify this, yeah, rational function? Because it is not, x is not equal to 0. Why don't you, x is common? So of these two terms, why don't you simplify that? Yeah, so x is common. I take x, so this is the common factor of these two terms, and I take it out. So then I left with x and -1, right? And in the denominator, yep, so we have 2x, and when x is not equal to 0, so because x is not equal to 0, you can cross this off. Then as x, yep, now let's consider the limit as x approaches 0. So this function, yeah, so this term goes to 0. Then this rational function goes to 1/2. So the 1/2, so if this function is continuous, this limit should be equal to the functional value. That means functional value is k, then k is, yeah, should be equal to -1/2. Yeah, this is the last question. Yep, so so f is defined for all real numbers, and this is, it takes this rational function whenever x is not equal to 1 and 2, and if is equal to 1, the function takes -3, and when x is the functional value at 2 is 4. So here you have a rational function. Why don't you simplify this? So you can so express this as 2 factors. Let's do that. I factorize the denominator. So this is the factorization of the denominator, right? So x squared negative x3 times plus 2. So since x is not equal to 1, you can cross this off, and we know that x is not equal to 2. This rational function is defined. So you can see that as x tends to 1, this numerator goes to 3, denominator goes to -1. So that means as x tends to 1, this function goes to -3, which is same with the functional value. So that means f is continuous at 1. So what happened to other point? Let's check the other point. As x approaches to numerator approaches 6, because 3 times 2 is 6, and the denominator is not defined. So because of this, as x approaches to denominator becomes so this term getting smaller and becomes 0. So therefore it is undefined. So therefore f is not continuous at 2. So this one, so but other points are okay. F is continuous except at 2, right? So we have to avoid this point. So at 2, f is not continuous.